I'm going to present on behalf of Dr. Katie Shanks first, so I'll just minus that a sec. Katie couldn't be with us, unfortunately, but I've got some slides from her, and we have done a number of talks recently. I'm not going to spend very long on this, and I'm not going to do it justice. But as well as working with window glass, which is not recycled, we only recycle container glass, effectively. We've also got a situation where we're going to have to handle all our solar panels as they come to the end of their life. And they are, well, I'll explain it as we go through. So I'll just start this from the beginning. So I am not Dr. Katie Shanks, but I met Katie working with Art and Energy many years ago. And her expertise is in photovoltaics applications. I'm really interested in the fact that she's talking about solar concentrators, because we've got electric furnaces, and what we can do is use these photo-concentrated systems to have free power to run things like a glassworks, and that would be ideal. I'm also interested in being on this farm because there's methane, and I can run that furnace on methane. I can put a CO2 recapture system, which I promised I wouldn't talk about, but we can end up with free energy, and we can tidy the place up while we're doing it. I'm going to carry on with this, though. We did a talk recently, Katie, myself, and a chap called Matt Burnell from a company called Resolar. Matt has been looking at taking these panels, and we've been working on ways of splitting the glass from them and finding uses for it. And we actually presented to the Engineering and Physics Sciences Research Council recently. So I've just lifted some of these slides from that on behalf of Katie. Now, these solar panels are crammed with antimony. I say crammed, it's got enough in there to be a worry. Back in the 90s, they banned lead in glass. So the Chinese, who've produced all of our solar panels, I would imagine, or many of them, replaced it with antimony. I can't tell you, hand on heart, how much antimony and how dangerous it is, but it's 10 times worse than lead. It's a lot worse than lead. It's worse than arsenic. And these panels, our solar panels, are loaded with it. And they're going to go to landfill, just the same as our window glass, end-of-life building glass goes to landfill, because it's too expensive to process it. Large industry can't do that. They can't afford the logistics to do that. But me and a hammer can, on a farm. I can sit there and quite effectively smash up bits of glass. But this is what got me interested in working with Katie, was A, the possibility of, we've got some solar concentrators over there to make them for her, and B, trying to solve this issue of what we're going to do with all of this horrendously toxic glass when it hits our landfill. And there you see, she's done this, upcycled glass, being part of the answer of how we can do it. We can take waste, it can come into the farm, into upcycled glass company. We're actually now physically making the designs that she's had in mind for years and years, but nobody's been able to give her one. Nobody's ever been able to make one of these for her. So that's exactly what I did, working alongside Katie, is to actually produce the prototypes, and that will then hopefully go into production. My idea has always been that we're going to have a number of sites, small setups, and scale is the issue. If we can't deal with these masses and mountains of end-of-life building glass and solar panels, a very small unit can work in the local area and just take the solar panels as they come in. We can smash them up and we can make solar concentrators. We can make beautiful objects. We can then have another life for it. The antimony's still in there, it doesn't bleach out. We're not actually creating glass from batch, we're not putting emissions into the air, we're just reheating it and reshaping it. At the end of that second life, it can go to an art college to be used for casting, because in changing the nature of this, we've processed this stuff, made it softer so it flows like lead crystal. And now it's a really good, valuable material for students to use and artists to use to cast into. This is probably not what Katie would say, but this is what I see. Sorry, I'll carry on. And this is just basically casting into a CNC milled piece of graphite that I've made myself, because I do a little bit of CAD work as well as the glass work. And also I made a quite complex two-part mold to make these. And it's just, you take the lid off it basically, and you take these little tiny kind of solar concentrators. Now what we can get with this is like a magnifying glass, concentrating the rays of the sun. Instead of your solar cell being this big, we can get the same amount of power out of one that big, using one of these round things which take the sun from any direction and direct it straight into the solar cell. I love that. I think that's fantastic because it gives me the opportunity now to run my furnaces, all my gear, and also it gives me something to do with this waste, somewhere to channel it to. And this is myself and Katie and Matt actually making the blanks and some frogs, which are in the back as well, because we've got to do something else with it, and the solar concentrators as well, the components. These are very small batch pieces, obviously, but they work. What I've done, of course, is I've actually just cleaned the bottom there, ground the base, and so that's as they come out of the furnace. A little bit of cold work on there, and you've got your solar prototypes. They wouldn't be manufactured like this, but they could be. We could sit there in a unit as small as this and make prototype objects for new technologies and new power sources, let's say, green initiatives. This is the one that I can kind of point to and not know much about, but I can tell you that one of these is lead crystal, which is obviously an optical glass. It's an expensive glass, and the lead is, let me have a look at this, if I can see which one it is. Yeah, it's the red one, I think. Yeah, so the red one is good all the way around. Yeah, some of them are really not so good here, but good at the top on this side. This is the angle of the sun, by the way. But the red one is what we're aiming for. We've made two glass types. It's crushed up solar panel glass mixed with a standard studio cullet, so the waste from a studio process. And also I've mixed it with old lead glass that have come from basically waste objects that we've identified. So I'm actually using commercial waste and mixing the PV glass into it. One of them is, let me just check now, is the brown one, and the other one is the blue one. So the blue one is better than lead crystal on this side of the range of angles, and the other one is better than lead crystal on the opposite side. So it's comparable. It's not as good, but if you put one of each and one of each and one of each, and you fill a field full of that, imagine what power you could produce, and it would be more efficient than lead crystal. What we've done with waste is actually produce something that is very, very valuable in terms of the material. I think what we've done anyway. But that's kind of what Katie has been doing. She's been measuring this. So we've actually got some tangible evidence rather than me saying, well, that looks shiny, which is as far as a craftsperson like myself can go. And I think the strength of this is basically Katie, Sarah, myself, Andy, and the other people within Upcycle Glass that have actually created something that I'm extremely proud of.